Hello everyone, welcome to Clean Coder YouTube channel. So if you are new to this channel, I'll highly recommend you to do subscribe this channel. So let's move to the problem statement which we'll be going through today. So we'll be solving lead code problem number 122, best time to buy and sell stock 2, which is a medium level problem. There is also a part 1 of this problem which is already covered. I have already made video on that. So I'll attach a link to that problem statement in this video. So let's get started with the problem statement. It's given that you are given an integer array prices where price of I is the price of a given stock on the ith day. On each day, you may decide to buy or sell the stock. You can only hold at most one share of the stock at any time. Okay. Or you can buy it and then immediately sell it on the same day. It's given. We need to find and return the maximum profit which we can achieve. Cool. So there are certain examples which are given to us. There is this example 2, example 3, and there are constraints. The price length is between 1 to 3 into 10 to the power 4. Cool. And price of I is between 0 to 10 to the power 4. Fine. These test cases, let's go through them over the whiteboard. So this is the first test case which is given to us. So the price on 0th day is 7, on first day is 1, second day is 5, and so on and so forth. So if we make a graph for these, the graph would come out to be like this. Okay, so this is the graph for those prices. So what we want to do is we want to maximize the profit, and we can hold this stock at most one time, and we need to sell the stock before we can buy. Okay, considering all these constraints, what we can do is we can buy the stock at local minima and sell the stock at local maxima, and we can repeat this process. Okay, so for this test case, the local minima is this point and local maxima is this point. So we'll execute a transaction, and the profit which we'll get out of this transaction is 5 minus 1. Okay, this transaction got executed. Now we can again buy at this point. This is the local minima and this is the local maxima, and again we'll execute the transaction. So the transaction would yield us a profit of 6 minus 3. Okay, this is our total profit. This comes out to be 4 plus 3, which is 7. Let's compare our answer with the answer given in the problem statement. So yes, the answer is 7 and our answer is correct. Now an obvious question which comes to our mind is like, can the line endings or the starting or ending point of this graph be a critical point where a local minima or maxima can exist? So the answer to that is yes. These could also be local maxima or local minima, and we need to check them also. So you'll see that in the next case these are also local minima or local maxima, and we'll cover that in the next test case. So let me move to the next slide. Okay, so for this test case, if we plot the graph, we can see that the local minima is here. This is the local minima, and local maxima is here. Okay, local maxima, the local minima. So the total profit which comes out to be is 5, the price of the stock at this point minus the price of the stock at this point, which is 5 minus 1, which is 4. Okay, so this is the total profit in this transaction. So let's move to the next test case, or the final test case, which is given in the problem description. this is the test case. Okay, so for this test case, we can clearly see that uh, uh, like for this test case, the this is a monotonic decreasing graph, right? So the price of the stock is continuously decreasing and we can't make a profit. There is no local minima here, right? We can't make profit by executing any transaction from this graph. So the maximum profit which we can uh, yield from this type of price graph is zero. Like we need not do any transaction. Let's compare our answer with the one which is given in the problem statement. I think it should be zero. Yeah, it's zero, and the reasoning given also. There's no way to make positive profit. We never buy the stock and achieve the maximum profit of zero, right? So yeah, this is the third test case. So I've explained you the test cases. So let's pause here for a bit and like we can think a bit of how the solution could be and how the code would look like, and how we can solve this problem in an optimized time and space complexity. So you can pause the video here and you can pull out maybe a pen or a paper and give it a try. So okay, I hope you gave a good try to this problem. So let's check out the code which I used to solve this problem. So let me go through the code quickly. So there is a function maximum profit which is given to us, and there is an array of prices which is given to us. Okay, so we need to return the maximum profit which is int. So the variables which I have taken is p is stock purchased. This is a boolean parameter. If we purchase a stock, we'll set this to true, and if we haven't purchased the stock, it's false by default. So the second parameter is pi, which is like the stock is purchased at which index. So while calculating the profit, we might need this index. So the third parameter is the actual profit, which is our answer, and we are finally returning that also. So okay, now there is a for loop. Let's see what we are doing in the for loop. So there's a for loop which is from the start of the array to the end of the array, and there is this if block. Okay, is purchased, not of is purchased. What does it mean? Like this is when the stock is not purchased, right? This would only execute when stock is not purchased. Let me write that. Stock not purchased. Okay, and this else block would only execute when stock already purchased. Okay, so this is the significance of these two blocks. So let me go to the inside. So there is another if block which is handled specially, right? Why? If I is not equal to 0 and an I is not equal to price dot length minus 1. This is the starting index and this is the ending index, right? The first and the last points are like special and we need to handle them a bit with more care. So that's why I have kept them in a separate if block. So okay, inside this if, what we are doing, so this is nothing but we are checking that whether it is a local minima or not. Like price of I minus 1 is greater than price of I, right? And price of I plus 1 is greater than price of I. So what does this graph depicts? Like this is the V-shaped graph, right? So I is this point, something like this. So what I'll say is I have purchased at this point, so I'll set the is purchase flag true. I'll save this index in the pi variable. Okay, so this I am doing here, and similarly if it's the like I is not equal to price dot length minus 1. It's not the last index, right? I is not equal to price dot length minus 1. It's not the last index. What I'm checking is uh, this type of graph, right? This type of graph I'm checking. Price of I plus 1 is greater than price of I. Whether I can buy here and sell anywhere else, like is there a local minima here? In that case also I'll set the is purchase true and I'll save that index. So these are a bit of special cases handled here. So let's check out the else block now. Again, here I was checking for local minima. It is exactly opposite here. I'm checking for local maxima. So if the graph is like this, I'll book the profit. I'll yield the profit. So if price of I minus 1 is less than price of I, this is I minus 1. This is I. This is I plus 1. So here, like, I can yield some profit from this transaction, right? So what I'll do is I'll set the is purchase flag to false, and I'll add whatever profit I am able to make, and I'll keep that in this profit variable. Similarly, the special condition, if when I is 0, I'm handling that. Sorry, when I is not equal to 0, I am handling that here. Okay. So what we can do here is like we can check the previous one also. Right. We can check the previous one also. If it's 0, then we can't check I minus 1. It's just like that, handling the first index, and here handling the last index. Here we need to handle the first index, here we need to handle the last index. So it's just like that. Some special base conditions are used. So let's check the time and space complexity of this solution. So the time complexity is pretty straightforward. It is O of n, since we are doing only single iteration, single traversal of the array. So it's O of n, and space complexity is O of 1, because we are not using any special data structure or auxiliary data structure. So this is all I want to talk about this problem statement. If you liked my explanation, and if you liked this tutorial, do give it a thumbs up, and thanks a lot for watching this video. And do like, comment, subscribe, and share this video, and you can subscribe this channel. And yes, have a great day. Thanks a lot. Hey guys, do check out this Instagram channel, Clean Coder Community, for all the jokes and memes related to software engineering. Thanks a lot.